everyone. I'm glad to see so many people. My name is Ilias, and I'm here today to talk to you about building and evolving microservices. A little bit about me. Actually, it's the first time I'm doing this presentation, and I like usually to practice with some of my colleagues, but recently I've been on sabbatical, and I'm usually a tech lead at ThoughtWorks. I've been working with ThoughtWorks for more than 7 years. We are a consulting company that makes custom software development and consulting around IT services. I've been in Rome 15 years ago for my first presentation. I was on PHP development at the time. And along this journey, I've been working on different stacks, different projects, more than 20 teams in the last 7 years. And some of these were also microservices projects, especially in the last few years. So I want to talk to you about this journey. And if you can find me on Twitter, and you can also, I usually talk more about some of my passion that are photography and other social stuff. The presentation today will be around 3 themes. The first one is about what are microservices. How many of you think I already know what are microservices? Can you raise your hand? And okay, half of the people. So I will try to go very quickly on this part. Then I will talk more about benefit and challenges that I met in my experiences and some of the patterns I met. And slowly go into some stories and some practices that I think are relevant and for me were very important to adopt. The inspiration for this talk, I have to give credits before we dive in, actually comes from one of my colleagues, Dama Degani. She's a technical principal in ThoughtWorks San Francisco, and she also gave me inspiration about this talk. Microservices. What are microservices? Also, being quickly, I will leave a lot of references. Other people define it. You can look up on the web this article from Martin Fowler and James Lewis, which are also 2 of my colleagues, and they give a more detailed explanation. I will also only focus on some of these characteristics. And obviously, I also want to recommend, well, the cover is green, now looks blue. Some Newman book that covers this with many details. Actually, I think I was just lucky and privileged. One of my first projects 6 years ago was with Sam and James Lewis. I was working in ThoughtWorks London at that time. And we started building this new platform from one of our customers. And we were using, microservices was not a name, a thing yet. And we were using DevOps, we were building small services, decoupling some of our data behind each different services, and tried to use some techniques to do mocking services and doing process testing for this. And that project was a failure. Actually, we were unable to describe what was the value behind this architecture and what was that we were achieving. After 2 months, we were still delivering infrastructure and components that we were hoping to reuse later. And it was not a happy story at the end. So I think it's important that we understand what we do, why we use some, microservices and what they are. Sometimes I hear people saying, I'm building one microservice, and microservice is an architectural style. It's not about one component, one service on its own. This is a definition that comes from some books. Small and autonomous services that work together and built around a business domain. And I highlighted what I think are the important parts. Small is obvious for everyone. It also comes from the word, but it's important that are autonomous and we can deploy them independently. And then there is a concept about try to build those around a business domain. These are some of the characteristics that you also find on the article from Martin Fowler. I picked up only some of them. The first one, it's obviously about building it around components in our architecture are separate services. Instead of having one service that we replicate every time, like a monolith, maybe with a single database, we have different services, each of that with a different business logic in it. When we talk about built around business capabilities and business domain, often you hear the Conway's law. That was mentioned a couple of times also in the presentation yesterday, so I'm not gonna repeat it, but it's the idea that our architecture ends up mirroring the communication structures of our organization, and the other way around as well. So they tend to influence each other. It's important in microservices a culture of automation, from continuous integration, continuous deployment, infrastructure automation. So building all of this, because the more services we have, the more difficulties to manage all of this. And not often is mentioned, so I will spend 2 more words on this. It's the idea of having smart endpoints and dumb pipes. What I mean by this, an example is, in the past, I've been in few organizations, especially big organization, banks, big retailer. They tend to have a ESB, enterprise service bus, that integrates different services. And that ends up, the idea is that gives us some capabilities like reliability of our messages, help us in integration, help us translating different formats. But often happens that when we have these type of components, they end up orchestrating the whole system, and they end up having business logic in them. So this is something we have to avoid. One sentence that I like to use for this, it's to use choreography over orchestration. Choreography, you can imagine like a group of dancers that they work together following music, while orchestration is like a director that directs all the messages and tells who should do what at which time. So it's not that we should not use orchestration like BPM or ESB, but we should try to avoid that when we do microservices. And this gives also an advantage that we should try to use for those communication as much as possible standards. And I think most of the industry is now switching towards something that looks like REST or some variation of HTTP with some other protocol and formats in it. And most important, it's some of the organizations that I've met, they end up having a single database. After a few years, they build their first website, and then they maybe succeed in their business, they start having more customers, and they found the moment where they cannot scale anymore. I've been in an organization that was running a SQL server with 128 gigabytes of RAM 6 years ago, and it was the biggest machine available at that time. And they cannot go further than that. With microservices, we try to have each service and component with their own data. Each service should own that data and the life cycle of that data. That doesn't mean that is the only one having a copy of that. Actually, one of the struggles that I had the first time I was building microservices is we should not copy data around. Like, this service, maybe invoices is the one owning the data, and we should not pass it around. That's a common mistake. You should maybe create events that publish the information that you need and recreate projection of those data somewhere else. And actually, you should have a lot of copies of this data, a lot of caches around your system. But maybe it should only be one service that has the business logic for that entity and has controls some of the life cycle of that entity. Typical question, how small should be a services and how many? You can Google and you will find many answers, and the answer is it depends. It depends on what is your level automation and what is the language that you're using. You cannot measure it in lines of code, but I think many of us have a struggle of, actually, how many of you think I have a system that is too big at the moment to handle? Okay. I see many hands. So you have already an idea of what too big means. And I think there is this line, like kind of this trend in when we try to split up our services in smaller components. So many of us probably are here, and the productivity starts going down because our big system is bigger and difficult to maintain, and we struggle. And then we say, okay, let's start splitting it in smaller pieces. But I think there is a danger. If you go too fast and too quickly, you end up in that moment where you have too many components, you don't know who is calling which services anymore, and you cannot maintain this. There are mitigations for this, but I think there is a main problem in this. I call it the enthusiasm regret principle. Because these architectural changes have a slow feedback, we end up, I want to try this new thing. There is Martin Fowler talks about it. And we start with a lot of enthusiasm, and we break our services in small component. But we feel the effect after few months, few years, when you end up with 20 services maintained by a team of 5 people, and maybe other teams in the organization that don't know what these 20 services are doing. And you will feel this pain only after some time. So start splitting your services early, but go step by step. And you will find what is appropriate size for you. Many people tell, but isn't this just good service-oriented architecture? And I think it is. It is a style of doing service-oriented architecture. And we live, I think, nowadays in a moment where our industry is also driven by hypes. And someone just needed to rebrand the good service-oriented architecture in microservices. And this, it's part of our ecosystem in IT. I've been also in organization where people say, and organizations say, we want to attract good developers and we want to attract talent. And talent sometimes follow hypes. And sometimes we should put some barriers to avoid those hypes, especially when the feedbacks are slow. We should try to adopt them incrementally. In summary, taking a look at the clock, there are some advantages and disadvantages. Microservices is not the only good solution. Sometimes you should keep having your monolith. Advantages are speed of change. When I have to change a single microservices within my boundary, I can autonomously deploy it. Each team can have more autonomy over their what is in their boundary. And to me, those two are the most important. I put them on top. Many people mention also the other three, composability, like I can compose different services to get to new results and new features in my system. Independent scalability, if I have a invoice service that is under stress while my customer service is not under load, I can scale them independently. And technology diversity. I put this on the bottom because it's also connected to the hypes of microservices. Everyone is happy. I can do whatever I want within my services. I can choose Node.js instead of Java, and I can play with NoSQL instead of MySQLDB. And but you have to be careful. You usually adopt microservices in big organizations where we have multiple teams. If you start having too many variations, you start also having problem of who can work on which technology. And on the other side, there are obviously the equivalent disadvantages. So it's difficult to keep track of change across teams and across services. You will have more changes, and it's more difficult to change the REST API rather than changing a signature of a function in your system. Eventual consistency of data. When you start scaling and having copies of your data, you will have to start thinking about eventual consistencies, or you will be constrained by your transactional boundaries of your system. And integration cost goes up. Maintenance, when you have to switch context between services, it's a cost. And operational cost and needs goes up. Because we are running a bit late, I will go very quickly through this example. There is a reference from James Burney, that he's a colleague of mine, that goes through this very, very quickly. But it's a reflection about complexity. Let's think in abstract terms for a moment. We have few things that are working, that we can compose together to solve a problem. They can be modules, classes, they can be services, can be whatever. And if I have 4 of these, I can make 6 combinations. And complexity goes up very quickly. If I have 5 of these things, I can have 10 combinations. And so on, and it goes up very quickly. It's less than exponential, but goes up very quickly. So there is a complexity that we have to keep in our mind, that is thinking about, I have to solve a new problem and I have to compose those things. And the more things I have, the more complex becomes. But in reality, I need only some of this connection. In a big system, I might have different domains and different things, and think that this is very complex to keep in my hand. Now I'm usually only using a visual metaphor, but you can see this also in your code and in your systems. And we think that by putting boundaries and maybe putting some constraints about only through a different protocol or a different way of communicating we can communicate, this is less complex. And this at first, it looks like it is. In a way it is. When I have to solve a problem inside of the boundary, it's less complex. But if I look at my system as a whole, it still has a certain complexity, which is the same as the system divided into boundaries. So to solve a problem, the complexity of a system that solves a problem is always the same. I'll summarize into this quote, that is, there is a minimum level of complexity in every system. And by using microservices, we cannot reduce it. We only reduce it inside of a boundary. This only can move the complexity around and gives a, we actually add complexity because we add boundaries and we add different protocols and we add constraint on the system. So the complexity in a way goes up and in a way goes down. So this is, I think, is key to think when we adopt microservices. And I think it's also summarized by this quote, that if we have a poorly structured monolith, we will not get anything better if we put microservices. So microservices, they cost. This is an idea. Also, there is a link of Martin Fowler's blog. You can read that for more details, but when we start building something with microservices, we have to pay a cost in automation, in infrastructure automation, in setting up using different technologies and tools, and so on and so on. After a certain limit, as our system grows in complexity along this line, there is a moment where we have a trade-off. In our monolith system, we start feeling the pain of being unable to change it because it's one single system, too risky to change and too complex. And with microservices, we can do this change autonomously and independently, so it starts paying off. So in the beginning, and also this reflects also the story of my first failure. We started from the beginning with microservices, building something new, and we were unable also to tell our customer why we were doing and why it was more expensive, and if it was the good idea. From doing it from the beginning, there are actually many people say, if you are a startup and you are still finding out what is your business model and your product, you should start with the monolith. You should not start with microservices. You should build something first that gives you result, and you can change it, iterate, throw it away. And then maybe your organization and you start being successfully and you have multiple teams that you can work together. And at that time, maybe you can start dividing it in microservices. I've been, over time, working in different projects, and I've seen also different adoption journeys. I will go through some of these, but one thing that I think is important is choosing your first services. So you already have a system and you want to start building something more granular and adopting new practices, that we will see some of these practices later. You should start with a service that is maybe low risk for your business, and you start with a service that maybe is more decoupled by the rest of your monolith. So choose carefully this. This it's also a key criteria from success and failure of your, maybe you're running an initiative to start building microservices and change your architecture. And it's a choice that can bring failure from the beginning. These four are some of the patterns that people described as something you can start with. This is described in SAM book, so I will not go into detail, but it's the idea you have a monolith that is still in a good shape, and maybe your service has some data structure into it, and you start to recognize that some of them can have some dependency, but they can be splitted around. And if you are arriving early enough, you can just split it into small services. Usually, what are the dependencies between your tables or your objects inside of that services? They become dependencies between your two services. It's hopefully the happy path. I've been in other projects where this system were legacy system, and I call this pattern the monolith in a coffin or a box. For example, I was working in an organization which had a 10-year PHP system that was deployed in a single server. They had different branches of the same application, and they were manually copying files and configuring on this single server to make it work. What we decided at that time is, okay, we are going to automate this this single service and monolith, but we are going to try to not to touch it as little as possible. We had help from the organization, but we started building new products around it and build 2, 3, 4, 5 services around. And after some time, you get some confidence, and you can start breaking this down. But don't try to do it at the beginning if your level of confidence is low. This is an example of another project I've been working in Germany. This was a big, we can consider similar to an e-commerce platform, an online marketplace. And they had the typical problem of they were unable to scale their database, and they were being successful and having a lot of traffic on their system, but they were unable to move fast enough in the e-commerce ecosystem. Their competitor were there going faster. So we went through this strategy. So the first thing we did was to use simple scripts. You can get data with triggers, copy them from your database, and publish them in an event stream. In this case, there were a dual advantage because we were also pushing this data to a different data center in the cloud, and we were doing 2 transformations at the same time. And we started with only read-only data. So you copy your data, you start building your services, and your organization is learning building read-only services is easier. And you learn some practices of continuous delivery. You learn how to deploy things in the cloud. And after some time, we also started reducing risk of this system, because after some time we switched the live traffic reading from that side, from the cloud side, and we started having less risk on the old data center side. And at a certain point comes the difficult part. You need to start building new services and move also the right part of your system in the cloud. This is, you can imagine, like, is a CQRS at architectural level. Like on one side, you have the write and the create part of your system. And on the other side, you have the query and the reading part. So we started splitting them, putting some queues in the middle. And these actually ended up as a long project, a big change and transformation for the organization. But at the end, it has been successful. One recent example, the slide is not working. I'm going to talk about it. There is my last customer I've been working with. It's, again, similar industry. Was stuck with an old enterprise service bus implementation, a typical system that they bought 6, 8 years ago, and they're paying huge licenses for it, for the interfacing with Salesforce and other few systems. This organization was already mature enough, was already adopting many automation practices and many continuous delivery and DevOps. And they decided to split this enterprise service bus in 5 different services. So that's another example. You can adopt it after a while that you know that you can, with confidence, work with practices of evolutionary architecture and continuous delivery. What time is it? So 36. I'm gonna mention only these are also, there is a longer presentation, and if you're within this presentation, I pointed out a lot of references because these are the presentation that helped me the most. There is a very good presentation from Stefan Tilkov, Microservices pattern and anti-patterns. If you're interested, you can, for each of these can be, we can talk a few minutes, but I will only mention them. Typical errors that I also faced, so I only selected the one that I also recognized and I met in my last few years. We start building anemic and entity services. This happened to me in a retail project. We had different systems, the stock management and the design systems, and we wanted to improve the integration, and we built a single services managing the life cycle of an item that was not doing anything except connecting to systems. And after a while, it became only a burden to maintain. One of the principles that we'll see later, it's we tend to come, many of us, I think also from my background, I studied computer engineering, we talked a lot about reuse. We want to reuse libraries, we want to reuse the code that we write, and there is a risk. On one side, you want to save time by reusing components. On the other times, you want to keep autonomy of your teams. So when you start adopting this architectural style, you will find out that, especially when it comes to business domain, business rules and flow process in your business, reusing code, it's not a very good idea. If you want that logic should be maybe in a single service, is a good reason for having it together. But try to reuse libraries that help you in a little infrastructural thing or cross-cutting concerns, but limit the reuse of business and domain entities. I will skip some of these, and I will mention the self-contained systems, which is a kind of contraposition to front-end monolith. I've seen both of these. You start building your many microservices on your backend, but then you have a single page application. And you have constraints of how this is refreshed in the browser and how do you split it, but you want to keep it still a small bundle that you can easily update, and you want to update parts only of this bundle, and this is a different problem to solve. I know of 1 or 2 teams that wrote a lot of custom code fighting with frameworks to try to resolve this. And you end up with a monolith in the front end. You build all your microservices in the back end, and then all the complexity gets stuck at the top. Another way to see this is try to adopt a different pattern. You can do this if your requirement in the front end maybe are a little less strict. Maybe you don't need to have a single page application with the fast transition between one page and the other and all of these. Stefan Tilkov is also one of the person that advocates for this style. It's your services should have a vertical slice of your architecture from the backend data, and maybe they should have a little fragment of the UI. And you can use reverse proxies and server-side includes to compose these fragments. You will struggle a little bit in how do you keep consistency between those fragment styles and libraries in the front end. But most of the time, it's a good pattern that allows you to keep autonomy for each team and has the advantage that each team is connected with the user, can autonomously deliver value and new feature for a user inside of their fragments. When I go back to the first failure that I mentioned, that we started building and adopting those practices without being able to articulate what was the why we were doing it. I think it comes to, if you're doing big transformation in your organization and you want to start adopting this project, this style of architecture, you need a strategy that is not only technology, but it's again is a mix of product, organization, and technology. They all go together. You need to when you adopt microservices, you need to change how your teams are structured. You want to use DevOps. You need to have a system person with system admin skills in your team. You want persons with UX skills in your teams, and you want cross-functional teams. But it's also product. Sometimes you want to build new products. Sometimes you want to change what you have before. There is an example. One of example that they publish a lot of information. The Scout team. They're an organization that has two verticals: Auto Scout and Immobilien Scout. They made many presentations on the topic that you can find, and they also published how they articulated some of these. And sometimes you have to put in relation strategic goals, architectural principles, and practices. If you are a small team, you can still do this by conversation in your team, but if you're an organization of 10 or more teams, you need to start articulating this in a structured way and publish this. There's also a concept of, when we talk about autonomy, talking about micro and micro architecture. Often teams are given the freedom to decide some of the architectural decision inside of their context, but we need to keep standards in the way we communicate and the way we integrate. This is terminology that we used in a couple of projects. So separating microarchitecture, you can make fast decision and move quickly. Macro are usually driven by consensus and driven across teams, with sometimes architects facilitating how we are doing this. Like, are we using REST HTTP? Is a macro architectural project. Are we using this validation library instead of another? Is a micro architectural concern. I will have to move quickly. You will see me jumping through slides. A lot of people talk about Conway's law. In reality, it's much difficult than what the story is often told. You will have people leaving teams, new services starting, and something that felt like a team with a clear boundary after sometimes becomes a mess. So be ready for this. Conway's law is not the only criteria of how you structure teams and services. There are people, there are skills, there are many other factors that you want to keep in mind. Something that when you start having separate microarchitecture concerns, you need to start thinking about cross-cutting concerns for each service. So this is an example of, you can also find this idea of fitness functions in the book from Rebecca Parson on evolutionary architecture, but the idea is that every team start thinking about what availability and throughput means for my service, because it's different from the rest of the services in my system. What does it mean, configurability of my system, because each of these will vary across them. And so each team needs to have those skills to have these conversations. Share almost nothing is also one of the criteria that we try to follow. Obviously, no shared databases, service templates, and exemplars is something that we often mention. And I want to show, we often talk about service templates, but what do they look like, what they are. So rather than reusing code, sometimes we create templates that allows us to quickly redeploy a new service. And some of the challenges I had, I start with a Hello World API, maybe built with the technical stack that we decide is the default for our organization, not the only one, but the default. And then we realize, oh, but we want also to build a page template, and we put build and deploy pipelines as code inside of our repository, metrics, logging. Each service should have a health check. And we also deploy infrastructure and automatically with load balancer, DNS entries, and so on. And then our system grows. We want status pages, correlation ID to log events across multiple services. And we want to automate having dashboards and alarms. If you practice, you build it, you run it, your team should be the one receiving the alarms of your service. And some cross-cutting concerns like authorization and you reach a point where this becomes too much. So be careful. Sometimes it's a very good thing that you should adopt, having templates that with very few commands allow you to deploy a new service. But at a certain point of this journey, you need to stop and keep it small. What you would like to have ideally is something like this. In my last teams, we were measuring not only how much time it takes for a commit to go to production, but we also were measuring, I have an idea, and how much does it take to create a new service? And when I was doing this 10 years ago, it was taking 3 months to get authorization, a test environment, and buying the machine. And nowadays, in the last few projects, we were able to do this in less than a day, half a day to have a service live in production. Try to measure this and keep improving it. Infrastructure as code is something you want to adopt. Good monitoring practices. I will have to skip quickly some of the slides. You will realize you never have enough monitoring, and the key here is to having monitoring as a service for your other teams, and define some common requirements that every service should have. When you are in trouble, you want good monitoring across your services. Testing will also change. Strategies there is a very good article that is also linked here that I will leave you for later reading. What I found is that if you have followed the idea of, or you are aware of the idea of a test pyramid where you have different type of tests that gives you different type of confidence and coverage. Sometimes you want something like this. You want a lot of unit tests and less exploratory tests. What I found in my experience is that you will start having more integration and component tests. Then because your service is smaller, and this is a bit controversial, maybe you will have a little less of unit tests and a little less of end-to-end tests. And you will rely more on testing that is close to your service boundary, because that is where the challenge is. A lot of people talk about consumer-driven contracts. It's a technique to try to avoid end-to-end testing and have tests that run autonomously. On this, my advice, many of my colleagues actually are enthusiastic about this. My advice is go carefully on this. I found it that doesn't scale with many teams. You start repeating some of the tests when you have many consumers of your service. And so be careful about this technique. Last but not least, it's the topic of resilience. This is another very good presentation from was the head of infrastructure of Netflix. I don't remember his name now. When your service becomes very big, each of these dots is a service at Netflix. There is a lot of hype about what Netflix and Amazon are doing, and you probably don't need it. But the real issue is that you will start having a resilience problem. One single service can bring down half of your infrastructure. There was a very good talk yesterday about this. And what you need to do is not concentrating on mean time between failures. So failures will happen in the cloud, services goes down, but focus on reducing the time to recover a service. So automated spinning up new services and so on. And there are a number of patterns. There is a link here that is not visible. This comes from another presentation that I recommend you to, when you reach this level of scale, start thinking about the resilience and about these patterns. These are the ones that I found more useful. Asynchronous communication, create events that are idempotent. That means if you run twice this event through your queues, it will not affect, it will have the same effect. And two of the patterns that are most useful are bulkheads of separating. For example, you have different connection pools for your different downstream services. Circuit breaker is the idea of stop hitting a service that is slow or not responding, and so on and so on. One topic that I mentioned, because you will have a lot of pain when this happens, is how do you handle incidents? Every 3 times in 3 of my projects, we started thinking seriously about this only after it was too late. When you have an incident, half of your system is not available. Before, if you have a single monolith, maybe you put 2 people in a room, and they know, I've been working on a little bit of everything in that system, and they solve the problem. And you try to, it's easy, you have one place to look at, one log stream where you can find the errors. When you have a distributed system incident, they become spread across your architect or your components. So you will require better facilitation. You will have to bring together people that are in different rooms and put them together to work to solve this problem. That means also people who never or rarely work together, and to work under pressure to resolve an incident. And what is important is that once you find a solution, you want it to avoid happening again, and it's more difficult to get to systemic improvements across a distributed system. While if you had a failure in a monolith, you can, I'm gonna change how I do deployment, and I have to do it in a single place. When you have a distributed system and an organization with many teams, it becomes harder. So you will have to spend more time in the learning process after an incident. So do this. Conclusion, there are many practices and many reasons and principles why we want microservice, but how do we go for this? Do it increment. I think I'm still working on this idea, and it's something, there are things that you must do. You must have infrastructure automation, good monitoring, and continuous delivery. And there are things that you can adopt later. Maybe having good matching of boundaries between the teams and the domain. Maybe you can delay that a little bit. You can do it later. Or you don't need to care about having like Netflix, Chaos Monkey in your cloud. You don't really need until you have 10 or 20 services. So take all of these practices, but think about them a little bit of the time. This is something to keep in mind, to not feel overwhelmed by all of these topics that we put around microservices. Takeaways, know your business and domain boundaries well. Build evolutionary architectures. That's more important than microservices. So if evolutionary for you is a monolith that you can change in your startup, do it. Automation, continuous delivery, DevOps, and monitoring are anyway something that is useful, and you should do it anyway, are a must. And evaluate other practices trade-offs. It's not only a technical change, but it's also organization and business product change. So, thank you. I don't know how much time do we have for questions, or so we have some time. Is there any question or curiosity? So, thank you.